Hi, everyone. Welcome to Unit 4. It's all about inequalities, less than, greater than, stuff like that. Just a reminder, if you want to write on this document, you can either open it in Kami or go to File. You can make a copy or just download it as a PDF. That's what I like to do. It makes it easier to write on. These are also available for pickup if you'd like a hard copy. If you want to do it on paper, some of you are doing it in a blank notebook, that's fine. Just don't forget to submit a picture. All right, so we're going to talk about inequalities this unit. I think you'll find it a little bit easier than the factoring that we were doing last. All right, so let's take a look. So first of all, inequalities are going to be, it's going to look like an equation. We're going to do some similar things, but it doesn't have an equal sign. If something is equal, it's equal, but inequality means that it's not equal. All right, so typically you're going to see a less than, which looks like if you hold up an L shape, all right, if you hold up your left hand, your thumb, and your pointer finger, if it has a line underneath, it's less than or equal to, okay? If it's going the other way, that's greater than or equal to. All right, now, on a graph, when we get into it, if it's just less than something or just greater than something, it's not equal to it. So you're going to show that with an open circle, which basically, if it's less than, it's going to be an open circle at that number, and you're going to shade towards the numbers that are less than. And if you notice, this arrow matches the end of your arrow. All right, if it's greater than, it'll be an open circle, and we're going to shade towards the numbers that are greater than. All right, if it's less than or equal to or greater than, it's going to be closed because the closed means it's equal to that number. And then if I shade to the left, that's the less than and then the equal. So if it's got the equal sign underneath, you're going to shade that circle in. If it's greater than or equal to, again, shading it in means it's equal to, and then we'll shade the numbers that are greater than. All right, so just some examples really quick. 3 is less than 8. This is a true statement. All right, you'll also see some that are false. X equals 8. All right, this is an equality. On a number line, you can show that. We don't typically do it with an equation because it's just one number. So on a number line, let's zoom in. It would be 7, 8, 9. Why is 6 afraid of 7? Because 7, 8, 9. I know, corny. All right, so on the number line, if 8's your answer, you're going to shade that in. Well, with inequalities, we use number lines because there's going to be a whole bunch of different answers. So this reads X, or the number is greater than 8. So think about things that would make this true. What could X be? Could be 9, could be 100, could be 8.1, right? Could be any of those things, but it can't equal 8. So we show that on the number line. So again, I'm going to put whatever number I'm at in the middle and zoom in. So it's, 6, 7, 8, 9, 10. So could 8 be greater than itself? Is that true? No. So I don't want to shade 8, but I want to show that my shading is going to start there. Because remember, it could be 8.1. It could be 9. It could be 10. It could be any of those numbers. So we're going to shade just this side. And again, the reason that we have that open circle at 8 is because, and not at 9, is because you got to think about, it could be 8.1, 8.2, 8.5. Any of those work too. So this is your end point. All right, and it's not shaded in because 8's not greater than itself. All right, but when we throw the less than or equal to, that equal to into the mix, it's a little different. So this reads, the number is less than or equal to 5. So it could be equal to 5, or it could be anything less than 5. So it could be 4, it could be 3, it could be negative 720. It could be anything less than 5. the possibilities are endless here. So to show that on a number line, I'm going to put the 5 in the middle. So let's just zoom in a little bit. So it'd be 3, 4, 5, 6, 7. Our endpoint goes at 5, but this time we shade it in because 5 is an answer. That's why it's a closed circle. And then we want to shade the numbers that are less than 5. So 4 would work, 3 would work, 5, or 4.99, 4.5, any of those. But anything to the right would not work. So I'm just going to shade everything on this side. Okay? So if it's just greater than or less than a number, it's an open circle to start your endpoint. If it's equal to the number, we're going to shade it in. All right. So let's get into graphing just a little bit more. Again, less than and greater than is the open circle, or the closed circle if you've got the equal sign. So let's look at a couple. X is greater than or equal to -1. So I'm going to put my endpoint at -1. It's equal to -1, so I'm going to shade it in. Now you want to fill it in with numbers that are greater than. So like 0 is greater than, 4 is greater than, -1. So I'm going to shade towards the numbers that are greater than. All right. Now this one's a little bit different. 3 is greater than X. Well, think about what numbers would that X could be. All right. Our circle's going to be at 3. It's going to be open because there's no equal to. But you might think, oh, I got to shade the numbers greater than. No, think about this. 3 is greater than what? What's a number 3 is greater than? 3 is greater than 2. 3 is greater than 1. We're actually going to shade that way. So what I like to do, if I see it written this way, is I like to put the X on the left-hand side. And if I'm going to switch sides, you want to switch the sign. So if 3 is greater than X, then X is less than 3. All right, and you're shading all those numbers. So just be careful if it's something like that. Make sure it makes sense. Shade towards the numbers that are going to make your sentence true. All right, and this last one's a compound inequality. Basically, what you're looking at is all the x's that fall between 1 and 4. And we'll do more work with these too. But so could x equal 1? Yes, it's equal to, right? So equal to 1, so I'm going to shade that in. But it's less than 4, so it's going to be an open circle at 4. And then think about the numbers that it could be. It could be 1, could be 2, could be 3. It can't be 4 though, but it could be like 3.5. Right? So we're just going to shade in between. There's no arrow on that one. Right? That's called a compound inequality because there's more than one there. All right. The last thing you'll want to do is be able to look at a graph and write your own inequalities. So your answers should all look like this. So this is showing all the numbers that are less than or equal to 2 because it's shaded in, right? So the numbers less than 2 or equal to 2. So to show that, always start with the variable. All of my numbers, all of my x's are less than or equal to 2. For this, it's showing all the numbers that are greater than -1. Are they equal to -1? No. All right, so it's just x. All of our x's are greater than -1. All right. So let's just look at a couple examples. If you want to pause the video and try them on your own, it's not a bad idea. If you're doing this on paper, you can just, draw a part of the number line. So take a minute and try those. All right, so let's see how you did. So all the k's, all the numbers are greater than -4. So I'm going to put an open circle at -4 because it can't be equal to -4, just greater than. So that means we're going to head to the right. And one little quick shortcut or hint with shading, as long as your variable's on the left-hand side, this acts as an arrow pointing in the direction that you're going to shade. But like here, the C's on the other side. So I'm going to put my circle at 5, and 5 is greater than or equal to, so it's a closed circle at 5. But the problem is a lot of times we think we want to shade this way because the arrow's pointing that way. No, think about numbers that are going to make that true. 5 is greater than what? 5 is greater than 4. So I'm going to be going this way. 5 is greater than 3. So what I like to do anytime I see the variable on the right, switch them. So if 5 is greater than or equal to C, C is less than or equal to 5. All right. And again, as long as that variable, sorry, it's a little sloppy. As long as this variable is on the left, think of this as an arrow pointing in the direction we're going to shade. All right, C, we got a compound inequality. All your x's are between -2 and 6. So I'm going to put my circles. It's just an open circle at -2, a closed at 6 because it's equal to, and then it's everything in between. And lastly, got a little problem here. X isn't by itself. What's going on here? We're going to have to solve, and this is what the next lesson's all about too. Solve for x just like you would an equation. So I'm going to get x alone. I see a -5, so I'm going to add 5. So I'm left with 2x is less than, don't change it to an equal sign, -8. And then if I divide both sides by 2, all my x's are less than -4. So now I can graph it. Open circle at -4, and I want to shade the numbers that are less than that, so to the left. And again, as long as your variable is over here on the left, think of this as an arrow. It's pointing that way. All right, so I would like for you to try the questions on page 3. So writing an inequality, graphing some inequalities, and then solving just like we did in graphing. All right, and we'll talk about solving more in the next lesson. Have a great day, and don't forget to stop by Math Lab if you're having trouble.